Dear students, I start with lecture 2 of Math 305. So here S is equal to n in n, where 1 plus 2 plus 2 square up to 2 raised to n minus 1 is equal to 2 raised to n minus 1. So this is one more sum, and we prove it means answering it. For n equal to 1 means if we have n equal to 1, it is 2 raised to 0 means only 1. Means it is 2 raised to 1 minus 1, so it is 2 minus 1, and therefore it is 1. And therefore 1 is in S. So by induction, the first condition holds. Next, we suppose this result is true for n equal to k, and we prove that k plus 1 belongs to S. Suppose k is in S, and therefore 1 plus 2, 2 square, 2 raised to k minus 1 is equal to 2 raised to k minus 1. Say this is equation number 1. And we want to prove this equation for k plus 1, and therefore okay, one term off. Now this is equal to 2 raised to k minus 1. This 2 raised to k is here, and this is due to equation number 1. And therefore this is 2 times 2 raised to k. 1 and 2 means 2 times. Means this is equal to 2 raised to k plus 1 minus 1. That means that this result is true for n equal to k plus 1, and therefore k plus 1 is in S, and therefore by first principle of induction S is n. That we wanted to do. Next, we are going to prove second principle of induction. Here, second principle of finite induction, S subset n, 1 is in S, and for k in n, 1 to k, there is a difference. In the first principle, what we say, whenever k in S, k plus 1 is in S. What we say here, 1, 2 up to k, all elements belongs to S. Then k plus 1 belongs to S, then prove that S is n. Clear? Now we are going to prove this is second principle of induction. Proof. We claim S equal to n. Suppose S is not n, let us let's define P equal to n minus s. Obviously it is not 5, because if it is 5 then s must be n. S is subset of n. So if P is not 5, and by definition P is subset of n, by well ordering principle T have least element. By well ordering principle T have least element, I say n. Therefore n in P. Therefore n is not in S, because as I said earlier, by definition S union T is n and S intersection T is 5. Means something is not in P means it is in S. Now this is the least element in T. Therefore there is no element less than n belongs to T. Therefore 1, 2, 3 up to n minus 1 belongs to S. As n minus 1 belongs to S, n minus 1 plus 1 belongs to S, and this is n. Therefore n is in not in S, n is in S. We get a contradiction. Our supposition is wrong. S is not n. Therefore S must be n. So this is second principle of finite induction. I hope you understand this very well. Dear students, we start with one more sum. Actually this is sum of very special sequence, Lucas sequence, in which we take 1 and 3 initial terms, and then this term is sum of both. Sum of both, sum of both, sum of both, sum of both. All preceding terms after third step is the sum of previous two steps, or previous two terms, whatever you say. Means an is an minus 1 and plus an minus 2 for all n greater than or equal to 3. Prove that an less than or equal to 7 by 4 raised to n for all n. So we start with the first term. Prove let S equal to n in n therefore 1 is in S as 1 is less than 7 by 4. If we put n equal to 1, it is a1. This is a1 is 1. 7 by 4 is to 1 means it is 7 by 4. Obviously this is greater than 1, and therefore 1 is in S. For a2 it is 3. Is equal to 49 by 16. Obviously this is greater than 3. 16 into 3, 48 means this is greater than 3. So this is true for second term. Now what about for the other terms? Now we assume that one, two, up to k minus 1 belongs to S. If k minus 1 now we suppose that here we are going to use second principle of finite induction, means second principle of induction, means we have 1, 2 up to k minus 1, all of them belongs to S, and therefore ak minus 1 is less than this, ak minus 2 less than this. Okay, therefore ak this is equal to 7 by 4 okay. Now we have this is equal to 11 by 4. Okay, can I replace this? (49 by 16) because this is less than 3. The value of this is 2.75. Okay, and value of this is greater than 3, and therefore obviously this is less than this, and this is what, 7 square 4 square, so this is equal to 7 by square, this is 7 by 4 square, so it is 7 by 4 is to k, means ak is less than 7 by 4 is to k. So by second induction principle, this result is true for all k in all n in n, means what we have after this step, therefore k is in S, and by second principle of induction S equal to n, and that we wanted to prove. Whenever you find some more attention on some steps, then you can pause this video, because whenever I am doing these videos, the 5 minutes of my lecture, you know that I pause this video whenever I am writing on the board, whenever I am erasing the board. If it is in within lecture, then I can't do that, because at that time I have to deliver so many important points to you. Otherwise I make it stop. My camera was off whenever I am delivering something which is just to see that. NCK n factorial k factorial n minus k factorial. So this is well known notation of NCR. Here I say NCK. The another symbol is NCK. See. So this is equal to n minus 1 minus k minus 1 and minus k factor. Means we cancel out the all previous k steps. K factor. Known formula, nothing new for you. Then there is a Pascal. NCK minus 1 n plus 1 CK. Okay. I think it is very easy to prove for you. Then Pascal triangle. Okay. Let me do it for you. Okay. NCK plus NCK minus 1 n factorial k factorial n minus k factorial plus n factorial a minus 1 factorial n minus k plus 1 factorial. Now the things which we can take in common, here keep it out. Okay. These things are in common, and therefore what we have now there, 1 upon k plus 1 upon n minus k plus 1. Okay, these things are remain there. In here it is k remain because this is in common. Here there is what we have in common, n minus k plus 1 is there, so n minus k plus 1 is there. And now we simplify this, it is n minus k plus 1 plus k upon n minus k plus 1 into k. So we can cancel out this case, and therefore it is n plus 1 factorial k factorial n minus k plus 1 factorial. So can I say this is n plus 1 minus k factorial. Can I write this? And therefore this is n plus 1 ck. That is Pascal formula. Try to get it, understand it. Then Pascal triangle. We start with 1 1 1 2 1 means sum of both 1 3 3 1 1 4 6 4 1 Sum of both 1, 5, 10, 10, 5, 1. So this is known as a Pascal triangle. And this is 1, 6, 15, 20, 15, 6 and 1. Okay, I will continue my lecture in the next session. I stop here for this lecture. Thank you very much.